So this is where your wastewater enters in a hopper, because you don't want to disperse your solids throughout your clarifier, so it takes a long time to settle. So this is where
Why is that?
our purpose is to minimize the settling time of the solids, so your clarifier size is small as possible. So the wastewater with the suspended solids enters into the hopper, and then these solids travel downwards due to the gravity. The solids have slightly higher density, so it travels down, and then there is a scraper mechanism, and there is a.
What's the main design parameter that we can mention?
So the main design parameter is your surface area of this outer circle here. So based on this surface area and your volumetric flow rate, let's say you have volumetric flow rate is Q, gallons per day, and your surface area, let's say EA square feet, because you need to match the units. Or you can say this is cubic feet. So this is what we call a surface loading rate. And there is another parameter which is called the weir overflow rate, which is, this is your weir. There's a baffle, because you don't want your scum to enter into your effluent. So the water, just for illustration, so let's say this is the baffle. The baffle will be secured to the outer wall through iron bars. So you don't want your water from here to overflow into the effluent channel. So what will happen is the water from here, only the water from here will enter to the weir, and then it will flow over the weir into your channel.
So only the volumetric flow rate in the area would enter as main parameters?
Yeah, volumetric flow rate, area, and your weir perimeter. This is your weir perimeter.
There's one more parameter that's really important.
Pardon me?
There's another parameter that's really important in settling.
Your sludge concentration, like the percent solids in your.
What the settling speed of the
The
particles?
settling speed of the particles pretty much almost same for for a sewage facility. It doesn't vary that much. So all those will be taken care of in that constant. And so whatever the surface loading rate and the weir overflow rate prescribed by the books or the regulatory agency, those
And
taken
just
into account here.
Remember, I'm playing the undergraduate student trying to
Okay.
design this for my AICHE project, which
Okay.
is where I have to do a settler, and it will be important to know.
Yeah, the settling, basically you use the Stokes equation or other settling equations, and that's how they come up with this minimum length of travel, the distance of travel, and then that's how you obtain your particle. Yeah, as a chemical engineer, that's how it should be explained to a chemical engineer. Like you use like Stokes equation or.
Thanks, now I can solve my AICHE problem.
Yeah.
I think you just broke the rules.
You can use then all kinds of inlet settling, drag coefficient, and all those, and then come up with the time for like to settle. Like your medium is water, so you know everything. And then, and of course, the sludge is available, very easily. Like you can go to Manhattan, Wastewater treatment. So if you want to do some experiments, empirical experiments with your sludge settling, go ahead and do in your lab. It's very simple. And, so that's what. Yeah.
I was going to just ask one question. You showed an optional chlorination unit, and because it's optional, you didn't talk about it very much, right? So a little bit of time to chat. But can you, again, kind of from the perspective of the undergraduate student, can you talk to me a little bit about what that unit is and what's happening there, and what needs to be known about it in order to design it?
Sure. Yeah. Actually, if any of chemical engineering undergraduate students, if they take a course in wastewater treatment, which is offered by civil engineering, this is a favorite assignment. One of the problems definitely will have this chlorination, design of a chlorination chamber. And you can relate very much to chemical engineering in the sense like first important thing that's done for a chlorination chamber is the residence time. You know, you plot your residence time and you know your how much time. Basically, we say the contact time for the chlorine and your wastewater. So that's a very important parameter in designing of chlorination, and that's done by our tracer study, like how we do the tracer studies, like non-ideal reactors, and